Factorial notation. For any natural number n, we have the n factorial, which is equal to n times n minus 1 times n minus 2, and so on, until we have 3 times 2 times 1. And then for the number 0, we have 0 factorial, which is always equal to 1. When we talk about factorial, it is the number of ways in which n things can be arranged or ordered. Let's have example number 1. If we have 3 things, A, B, and C, it could be arranged in 6 different ways. So we have A, B, C. It could also be B, C, A. We can also have A, C, B, or C, A, B. We can also have B, A, C, and C, B, A. So from this given, we have 6 different ways. Or we have the given 3 things. We have A, B, and C. So we have 3 factorial. That means from the number 3, so that's n times n minus 1. So our n is 3 minus 1 is 2. N minus 2 will be 3 minus 2 is 1. So we have 3 times 2 is 6 times 1 is 6. So again, we have 6 ways. Example number 2. If we have 7 factorial, so from the value of n, which is 7, we'll multiply all the other factors going to 1. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1. And that will be equal to 5,040. Example number 3. If we have 7 factorial minus 5 factorial. So for the 7 factorial, we have here 5,040. That is 7 times 6 times 5 times 4 times 3 times 2 times 1. Minus the 5 factorial will be 5 times 4 times 3 times 2 times 1, which is equal to 120. So we have 4,920. Example number 4, we have 12 factorial over 4 factorial times 8 factorial times 9 factorial over 2 factorial times 7 factorial. So for the 12 factorial, this is equal to 479,001,600 divided by the 4 factorial times 8 factorial is equal to 967,680. Then the 9 factorial will be equal to 362,880. And the product of 2 factorial and 7 factorial will be equal to 10,080. So dividing this, we'll get 495. And for this one, we'll get 36. So 495 times 36 will be equal to 17,820. Example number 5. So let us find for the value of n given the expression. So we have n plus 1 factorial over n minus 2 factorial is equal to 20 times n minus 1. So we change first our n plus 1 factorial into an expression having n minus 2 factorial. So for the numerator, it could be expressed as n plus 1 and then times n minus 1 times n minus 2 factorial. So we'll stop with n minus 2 factorial so that we have the same expression with the denominator and it could be cancelled. So as we cancel this, we'll have n plus 1 times n minus 1 is equal to 20 times n minus 1. So what are we going to do is multiply the whole equation by 1 over n minus 1 to eliminate the n minus 1 both sides. So therefore, we'll have here, so our n minus 1 will be cancelled. We'll still have n plus 1 times n is equal to 20. And then in that case, so again, this one will be cancelled using multiplicative inverse. We'll multiply the whole equation by 1 over n minus 1, and this will be cancelled too. So we have n plus 1 times n is equal to 20. We distribute our n to n plus 1. So we have n times n is n squared, and 1 times n is n. So n squared plus n is equal to 20. And then our 20 will be removed by adding negative 20 both sides. So APE, so we have n squared plus n minus 20 is equal to 0. So in this case, since we have a degree of 2 here, this is already a quadratic equation. So again, to find for the values of n given this quadratic equation, we can use the different methods in finding the roots. But let us use the factoring method. So the factors could be n plus 5 times n minus 4 is equal to 0. So again, we check. N times n is n squared. N times negative 4 is negative 4n. 5 times n is 5n. So as we add these two terms, 5n plus negative 4n is simply n. And then 5 times negative 4 is negative 20. And then we have to equate each factor to 0. So we'll have n plus 5 equals 0. And n minus 4 is equal to 0. And then find for the values of n. So for our first given, n plus 5 equals 0, that becomes n equals negative 5. And n minus 4 equals 0, that becomes n equals 4. So we only use positive 4 because we are looking for the number of object or thing. So it could never be a negative number.